So, you want to be an engineer, build Iron Man suits or gadgets like Batman or every other futuristic technology that you see in science fiction. Although that should probably be more like engineering fiction, now that I think about it. I'm here to tell you
that is not what engineering is.
At least practically, not in this world, in this universe that we live in. Although, thinking about it, that Batman stuff would probably be more practical. I'm thinking about the Batmobile in the latest movie. That thing was a beast. And I'm pretty sure somebody out there could create it. But anyways, people have this idea that if you go, for example, to study mechanical engineering, you're going to come out the other side knowing how to, say, build a car from scratch. You'll be able to design it, manufacture the parts, know how it works, all of that. And that is just fantasy. That's not real. The reality is you will be able to understand the fundamentals of mechanical engineering systems. So you will know how a car works, you will know the different systems that make up a car and how they work fundamentally. But to be able to build, to put all those things together, nah, man, that's not gonna work. That's just not a thing. But even without that engineering fiction, it's still quite amazing. Engineering as a discipline is still quite amazing, and the things that you can do with it. You don't believe me? Seriously, just look around. Look around you.
Look at this video.
The computer, this chair, the video thing that I'm using, the lighting, everything, that is all engineering. So reality can actually be quite fascinating and beautiful if people could just give it a chance and stop obsessing over fantasy. This is an introductory video where we're going to talk about engineering in a more generic way. We're going to have more videos in the future that will break down the engineering disciplines, where we'll talk about them individually. These engineerings include, of course, the more commonly known ones like mechanical engineering, electrical engineering, civil engineering, electronic engineering, and the lesser known ones like mechatronics, ceramic engineering, human engineering, volucentric engineering, earthquake engineering, and some of those I did not make up. So, what is engineering in this here universe that we live in? Let's try to give it a formal definition. Engineering is the application of science and mathematics to solve problems. Now, to put it in other words, whereas scientists are very much content with just understanding how the universe works, engineers think to themselves, how can we use these laws of the universe to make machines or systems that you and I can use? For example, Isaac Newton will discover the laws of motion, and then an engineer will come along and be like, I wonder if there is a way in which we could use these laws to create a system or machine that can drive us from position A to position B very fast and furiously, if possible. And that, ladies and gentlemen, is how cars were invented. And do not fact check me on that one. To quote Albert Einstein, everybody's favorite nerd, scientists investigate that which already is, and engineers create that which has never been. Now, he also had some negative things to say about engineering, but hey, it's all subjective, right? All opinions are relative. Get it? Relative. Like theory of relativity, Einstein. Never mind. A quick test to see if you're more sciencey or engineering could be asking yourself the question, if you are more interested in understanding how the universe works, unraveling the mysteries of the world, and then just leaving it at that, not caring about the practical applications of the knowledge that you acquire, then you are probably a scientist. If, however, you are more interested in the application of this knowledge, then you would probably be an engineering person. But the results are not conclusive. TNCs applies. So, what do engineers do? Engineers design, test, develop, modify, maintain, and install a variety of machines and systems. This is just another way of basically saying if it has to do with machines or a system of machines, then you most likely have engineers on just about every level of that process. Take a car, for example. If somebody has to design it and test it and make some modification to the original design if necessary, who does that? Engineers. And when the car is done and it's out there doing its thing, who has to maintain it? That's right, an engineer. The only thing is, these different engineers will have different levels of qualifications, from diplomas to undergrads to PhDs and all of that. But that is a story for another day. We could have a 1,000-hour-long video discussing engineering and all of its different aspects, but who has the time, right? So instead, I wanted to talk about one thing that I think is very integral to all of engineering, which is design. What is design? What does it mean to design something? Now, you know, in movies where you have that scene or that montage where a person comes up with an idea or an invention and then they spend hours or days or weeks in their lab or in the garage or in the bedroom soldering, welding, coding, doing all of that stuff and drinking copious amounts of coffee, and then comes out the other side like Jesus from the wilderness, ready to present to the world.
Yes! No!
That is not how design works. What is design in this here world? We're going to be referencing this book over here. I hope it appears when I do this, because that would be weird if it didn't appear. But we're going to be using that book to reference, to find a definition rather of what design is. So, what does it mean to design? To design is to formulate a plan for satisfaction of a specified need or to solve a specific problem. The process may result in the creation of something physical. Should this be the case, the design must be safe, reliable, competitive, usable, and manufacturable. Oh, and marketable. So no flying cars and hyperloops in there. You're probably wondering why, for example, flying cars are not a good idea. Let's talk about this whole flying cars thing for a second. Let's say you design and invent a car that flies, right? Congratulations, you're amazing, you're smart and all of that. But let's think about it more practically. This car has to exist somewhere. It has to fly, right? So imagine a lot of people flying cars. This would mean that you would need a whole different infrastructure for this, right? Presumably the same kind of infrastructure that allows planes to fly. But now you have a crap load of cars flying everywhere, flying on top of people's houses. And if a car were to break down in the middle of flight, it could crash into somebody's house. The levels of disaster are just too many to list. I'll link a video that talks about why this is such a bad idea. And this is the thing that you need to realize about innovation. It comes basically as incremental improvements on technology that already exists. And this is not a bad thing, because the people who created the original technologies in the first place were not necessarily stupid. Look, I'll give you a challenge. Look around you. Look at the technology that exists around you and think to yourself how you could have done it better. I dare you. And put your ideas in the comment section so that we can discuss them. One thing you will find is that coming up with stuff that is innovative and practical is not very easy. Anyway, I was digressing. Let's talk about what the process of design looks like. So what does design look like in this here universe that we live in? Well, there's a couple of steps to it, and we're gonna discuss them right now. Step number one, identify the need. This is where you identify a situation that you feel like needs to be fixed in the environment. Say, for example, you see a road that has a lot of traffic, a lot of fast cars, and kids struggle to cross that. And as a result of that, every other week, a kid gets hit by a car. You identify this and you're like, okay, this is a problem. Something needs to be done by this. That's you identifying a need. Step number two, define the problem. What does this mean? This means that now you become more formal about that need we spoke about. So for example, you might say there is this road, there's this route where there is high traffic and kids are in danger of getting hit by cars, that kind of thing. Now, on top of that, what you also need to do is to have specifications for the possible solution. What do I mean by specifications? I mean characteristics that a solution might have. So in this example of ours, possible characteristics might be to say this solution should allow students to cross safely with minimal impact on traffic. This solution should allow people to cross whether it's day or night, whenever. And it should be able to be used by a lot of people at the same time. These are specifications that you would give to a possible solution. Step number 3, synthesis or concept design. This then is where you start to get very specific about the solutions. This will include you doing a lot of research to find out what other people may have done to try to address the same problem. Because believe it or not, the problem that you will be facing is most likely one that has been faced by other people in the past. And they've probably documented solutions that they employed. So this is where you start to really look at the different solutions, and I guess you could list them down. In our particular example here, you might say that a solution is an overhead bridge that kids could use to safely get across the road. Or if you're Elon Musk, you can say children should have jetpacks, which will allow them to fly over the traffic, and everybody will call you a genius for it. Step number 4 would be analysis and optimization. This is where now you take those solutions from step 3 and you evaluate them to see just how practical they would be in your situation. Are they cost effective? Impact on environment? Can you actually apply them in this particular situation? Is it a sustainable solution? Now this step is very closely intertwined with the previous one, because obviously if you analyze a solution and then that solution is rubbish, then it means go back to the previous step, do more research, then come back to this one. So you can find yourself stuck in that cycle for quite some time. So already that montage is not looking so great. Now is it? Step number 5, evaluation. Now this is where you create, say, a prototype or some sort of working model of your solution so that you can test it. You test it to see if it meets the requirements that you had. Does it do what you need it to do? Again, if it doesn't do what you need it to do, what do? You go back. You go back to the previous steps and you keep going. It's like a cycle. Do you see that? It's like a cycle. You go to this step, and then if this one doesn't work, you go back to that one. It's a whole thing. It's a fun mess. So now let's say you finally managed to get yourself out of that mess. You've evaluated and everything works. You get to step 6, presentation. This is where now you present your solution to potential investors. Maybe if, for example, it's an invention. Now, this is where your communication skills are actually necessary, because what's the point of having a great idea if you do not have a way to communicate it or sell it? And for some reason, people seem to think that engineers do not have those skills, which is why they actually even have modules dedicated to that in engineering degrees. I wonder why that is. I really wonder why that is. Guess we'll never know. So the process I just explained right now is a much more general one as far as design is concerned. Now, as you study engineering, when you get into your specific discipline, the process will be much more refined and made to be specific to your particular thing. But I should tell you this, when you go study engineering, this is not where you're going to start. In your first year, second year, if you're taking the 4-year degree, you're not going to be dealing with design. You're going to be studying a lot of modules that teach you some fundamentals, and that are not going to seem like they have anything to do with what it is that you're trying to become. So for example, you might be studying mechanical engineering, and then in your first year, you're learning about, what is it that I learned? I remember I took subjects that were like chemistry, material was relevant. I did something to do with, there was some social science stuff in there. I remember there was some civil engineering modules in there there was some there was some electrical stuff in there. Stuff that felt like were irrelevant to me trying to be a mechanical engineer. So you will be doing that kind of stuff as well. It's only in your third year and final year where you will start to talk about design. But I promise you, it all connects. Most of you will not be lucky enough to find lecturers who will try to communicate to you how all of this connects, but it eventually connects. All of it is it's building up to try to get you to be the best designer out there, the best engineer out there. Anyway, that's all I wanted to say today, and I'll talk to you next time when I have something else to talk about. So, bye.